Welcome to qnawire.
Given the information for a chemical reaction in which we know the value for delta G naught, and we want to know what is going to be the value for delta G at a different temperature given the concentrations of each of the species. So for this, let's remember that delta G in general is going to be equal to delta G naught plus our T logarithm of the coefficient of concentration. So in this case, our value for Q, according to our chemical reaction, is going to be concentration of water squared divided by concentration of hydrogen squared, multiply this guy by the concentration of oxygen. Plugging in the values that we are given here in our problem, the concentration of water is 4.82 divided by concentration of hydrogen, which is 5.35 molar, and concentration of oxygen, which is 4.07 molar. And this guy is squared. So the value for Q is going to be equal to 0.19943. We can take directly on our calculator our logarithm of Q, which is going to give us minus 1.6123. Well, 2288, but let's run it out to 2123. Now, the very next step is going to be transforming our temperature into Kelvin, because we know that the values that we're going to require are going to be in Kelvin. So this is minus 0.9 degrees Celsius, which into Kelvin we need to add 273.15. So in this case, this would be 272.25 Kelvin. With this information, we're ready to finish our problem. Remember that the value for R is going to be equal to 8.30145 joules per mole Kelvin. So we can proceed right here on the side to get the value for delta G directly. So delta G is going to be equal to delta G naught, which is going to be minus 457.22 kilojoules, plus the value for RT, logarithm of Q. Of course, here we are going to require to transform these joules over here into kilojoules. So for that, we're going to introduce a factor that 1 kilojoule is equal to 1000 joules. This factor multiplied by our gas constant, 145 joule per mole Kelvin, times temperature, which is 272.25 Kelvin, times our logarithm of Q, is going to give us our final answer. So over here, the factors that are going to cancel, joules cancels with joules, kilojoules cancels with, kilojoules stays there, Kelvin cancels with Kelvin, and mole is going to stay over there. In general, remember that when we are calculating the delta G for a reaction, we are referring to 1 mole of reaction. So in this case, you can put in here 1 mole of reaction. It really doesn't matter. You can also put the value in delta G standard to be kilojoule per mole of reaction. But since it is already assumed that it is equal to 1 mole of reaction, then you can leave it like that. So in this case, our value for delta G would be equal to minus 416.87 kilojoules. So with that, it would be all. Thank you very much and have a good one.